All right, so you've collected all your data for the Hooke's Law part of this lab, and we will analyze that data later, but you can collect the data that you need for the extension part of this lab, and we'll cover the analysis for that extension more on Monday. So for for the extension of the lab, what you're going to do is take the 100 gram mass, you're going to put it onto your mass hook. You do not need your meter stick anymore. Put it into the equilibrium position, and then obviously keep in mind that in this case I would have 117.1 grams attached to my spring. You're going to pull down about a centimeter or so, and you're going to use Hudl technique to record the oscillations that you get. So with Hudl technique, you say to your partner, ready, go, release, and you're going to let it oscillate up and down. Now, one thing you'll notice is it kind of goes from pendulum motion to up and down motion, which is more complicated than what we're going to get into in this class. We're just going to focus on either up and down motions or pendulums that aren't attached to springs. And so when you analyze this to figure out what the period is on Hudl technique, what I would do is only look at 3 or so up and down motions and then get the average of those. If you do too many oscillations, you'll start to get that pendulum motion and it'll be a lot harder to deal with. So try and make it go up and down as much as possible. You know, pull down as straight as you can and just try and get it to go up and down enough that you can see it on the screen. Once you do that with the 100 gram mass, you're going to need a 200 gram mass. For that part, go up to the front of the room. Mr. Blum has a few 200 gram masses to share with everybody in the class. Get the 200 gram mass, add it on, record your mass, and just like before, get it to equilibrium, pull it down about a centimeter, and record it on Hudl technique. And then you will have all the data that you need for the extension, and you're good for the lab. See you Monday.